Hello everyone. Today we are going to solve LeetCode problem number 1, 2 sum. The problem says, given an array of integer nums and an target. So we have an array of integers with us called the nums, and we have an integer with us called the target. Return indices of two numbers in the array nums such that they add up to target. That means, let's say we are given an array nums 2, 7, 11, 15. And we are given a target 9. So we are required to return the indices of those numbers whose sum we add up to get the target. So over here, we would return 0, 1 because the number at position 0 is 2 and the number at position 1 is 7. If we add 7 and 2, we will get 9. We may assume that each input would have exactly one solution. That is, for each nums array given to us, and for each target value given to us, there is exactly one output array of two integers which would represent the position of the numbers whose sum would add up to the target. And we may also assume that we should not sum the same element twice. Now, imagine you are at a party with numbered cards. Each guest has a card with a number on it. Your goal is to find two guests whose numbers add up to target number, say 9. That is, you are given an array of nums, an integer array, which represents all of your guests at the party. And the values, the integers written in this array nums represents the numbers that each guest in your party carry. Now, one way to do it, that is, to find the two guests whose number add up to the target, is what everyone else would think at first would be that ask every pair of guests, do you two sum to 9? That's the brute force approach. It works, but it's slow, and you would have to ask a lot of pairs if the party is too big. And that is the brute force approach which is given over here. So, if we have an array nums given to us, then first of all, we'll initiate a variable n to nums.length. That is, n represents the total number of guests in our party. N represents the total number of numbers, the total number of integers written in the nums array. Then we will start the iteration. First, we will start with a pointer I, which will iterate through the entire array. And then we will start with the pointer j, which will iterate to the entire remaining array. That is, first we will take the guest number 1, that is guest at position 0. We will make him sit on the chair, and then we will start calling each next guest. So we will first take guest at position 0, make him sit on the chair, then call guest at position 1 and check if the numbers that guest 0 has and the number that guest 1 has, do they match up to give us the target? If not, we will throw guest 1 and we will call guest 2. We will check it again. Thus, the addition of the numbers that guest 0 has and guest 2 has, does that add up to target? If yes, voila, problem solved. If no, we will throw away guest 2 and we will call guest 3. We will keep on repeating it until we find that guest 0's number with some other guest's number add up to the target. If not, then we would make guest 0 stand, and we will then call guest 1 and we will make him sit at the chair, and then we will repeat the process. We'll not check guest 1 and guest 2, guest 0, because of course the sum of guest, if the sum of guest 0 plus guest 1 is not equal to the target, then it would not be equal to target the other way around also. So then we will start with guest 2. Does the sum of the numbers of guest 1 and guest 2 equal to 0? If yes, okay, great. If no, call guest 3. If no, call guest 4. In that way, first we'll pick up each guest, and then we'll call each subsequent guest to check if the numbers they have match up, if the numbers they have add up and match up to the target. Now again, this is the brute force approach that everyone would think, but it would be very, very slow if we have a large array. That is, if you have a lot of guests in the party, it would be very difficult to check if like which two guests, the number of which two guests add up to the target. So this is not a very good approach. Okay, let us review the code. What we are saying over here is, if target minus nums of I is equal to nums of j, that is the remaining number, if guest 2 is sitting on the chair, so the guest 2 will represent the number nums of 2. So the remaining number would be target minus nums of 2. So we will check if any subsequent guest has the number equal to target minus nums of 2. If so, we will return I comma j. That is, we will return the indice value of the guest which is sitting on the chair, which is I, and the subsequent guest whose nums of j was equal to target minus nums of I. Because ultimately then nums of j plus nums of I will be equal to target. So we will return the indice value of the guest sitting on the chair and the indice value of the guest whose number was equal to target minus nums of I, which would then add up to become like nums of I plus nums of j equal to target. If we find any of this, if the array ends and we are not able to find any pair which add up to target, we'll simply return -1 comma -1. Now Feynman would say there's always a trick if you think about what you really need. So instead of looking at pairs blindly, keep a little notebook, which we call the HashMap in Java, in which you write down the numbers you have already seen and where they are standing. So now, as each new guest arrives, look at your notebook, ask, is there a guest I already saw whose number plus this new guest's number equals the target? If yes, bingo, you found your pair. If no, write down this new guest's number in the notebook for future guests. Let me explain this. So, you have a party at your home. You have a bunch of guests that you have called over to the party. You have a notebook with you. Your goal is to find two guests and exactly two guests which will be present in the party whose number add up to the target. So you go into the party, you meet up with the first guest, and then you write up that guest's number and index value. Then you meet up the second guest, and then you ask yourself, is the target minus? Then you ask yourself, what that is the guest like? So that is there a guest which I have already seen, that is the first guest, whose number if I add to this new guest, that adds up to the target? If so, you return the index value of the current guest that you are meeting and the guest which you have already met, whose index value you have written in the notebook. If no, write down this guest's number in the notebook for the future guests. So what's beautiful here is that you never need to look back through every one repeatedly. Your notebook does it instantly. This is why the HashMap approach is fast. every lookup is almost instantaneous. So we define the number of guests in the party as nums.length, the total number of elements in the array. And then we define a hash map. The syntax to define a hash map is we write a map with a capital M, and then we define the key value pair in these two are greater than and equal to symbols. So here an integer is mapped to an integer. Then we give the name for the hash map. We call it scene. And then we create a hash map. So this all happened in the heap. And then we create a hash map actually in the stack using the new keyword. And then we declare that it's a hash map which maps to key value pair. This is the syntax to actually create the hash map in the stack. Then we start to iterate through the entire nums array given to us using the pointer I which is initialized using the for loop. What do? We enter the room which has all the guests which we have called for the party, and then we start meeting each guest. Now we define a new variable need, that is target minus nums of I. What is that? Let's say we meet the first person. Now let's say the target is given to us. We met the first person. Now if the number which is given in the first, so what we do is we create a new number need, which is what? Whatever the target was minus whatever is the current value, whatever is the current number that the current guest is representing. Then we check if the hash map contains need. That is, we check if our notebook contains a number need, but we are just meeting the first person in the party. That means our notebook is empty. So this block will be false. In that case, we will write the name, we will write the number that the person represents and the position of the person. Then we will go to the second person. That will be the person at position number 1. And we will define need again. We will say that need is target, whatever is the target, minus the number that this person represents. Is this need present in my notebook at this position? Is my need present? If the need is present in my notebook, that is, if the hash map scene contains a key need, this is the key. If the hash map contains a key need, then what do I have to return? I have to return a array containing two numbers. The position of the two people whose numbers add up to the target. So of course, like I is the number at the position is a position I is whom I am meeting. I just want the position of the person whose number added up to this current number added to the number of this current person gives me the target. How do I find it? Go to my notebook scene. Get the position of the person whose number is need. Go to my notebook scene. Get the position of the number whose value is need. So scene dot put, and if this doesn't happen, then open my notebook scene. Put the new key comma value pair, key that is the number of this current person and the position of this current person in my notebook. Go to the next person. Define need again. That would be target minus the number that this current person represents. Check the notebook. If the notebook contains this number need, then return the current value, the current position of this person and the position of the person whose number is need. Whose number is the need. So we will open the notebook. See if there is we will open a notebook. See if there is a person whose number was need. If it was need, we will return the value, the position of that person. Scene.get need will return the position of that number. And if not, we will open the notebook. we will put this person's number and the position in the notebook. We will keep on doing this. If we find a actual person, then we will get the true array containing the two positions whose number added to the target. If not, we will return -1, -1. This is a beautiful solution because you would never have to look back through everyone repeatedly. Your notebook does it instantly. Your notebook contains the number of each guest and the position of each guest. You just have to go to the next guest, calculate the number need, that is, do target minus the number that that guest represents. If that target minus number that that guest represents is actually present in your notebook scene.contains key need, then just return an array which contains the position of the person you are currently meeting and the position of the person who had need. That is why the HashMap approach is fast. Every lookup is almost instantaneous. Thank you, everyone. Bye.